Hi. So I gave this talk before, so I didn't change the title here. But basically, the big confusion I see with my students very often is they hear about conda, and everybody uses anaconda, mini conda, and conda, and then the company name. Everything is overlapping, so people have a little bit of a problem to get it. But so I want to explain to people a little bit what are the differences, what's the best practices, and then my tagline always to get people into this, because people are so scared of changing things that are working, is I show you that it is confidently able to be done, and no big deal, to completely wipe everything and reinstall your whole scientific Python stack in under 5 minutes if you have to. And that's how I lure the people into the talk usually. Okay, so when I have a presentation, sorry, when I'm in a audience room, I usually ask, and we shouldn't do a poll now, but I usually ask the people how many already are using a conda-based system, and then how many are actually very clear about the differences. And I think it's helpful to spend a few minutes on these differences, because they just make you less confused in terms of what's happening. All right, so this is a little bit of a trying to be a big graphical overview. I'm not very good with graphical design, so excuse the simplicity. But I want to guide your eyes first to the green box. That's where it says tool and conda. So the first thing to realize and to understand is conda is, technically speaking, the name only of the binary tool that you use to manage everything. You manage packages, and you manage the creation and destruction of virtual environments. So conda is the tool. Now the next term in the upper left, mini conda, that is a minimal set of packages that need to be installed into a new virtual environment, including the so-called base environment that's always installed when you install a conda system. So it's really the minimum set. It's, I think, last time I counted was 2 or 3 days ago. I think it's 10 or 11 packages now that are always coming into your minimal set. And this includes pip. And this is important for a standard problem I hear from students and colleagues. They install something with pip and it was error-free. And then they start their conda-based system and the package is nowhere to be found, import error. And that's because pip installations are always dependent on your current path or currently active conda environment. Pip always relates back to what set of Python is currently active. That's a very important thing to know and to tell your students when they start working with Python. Everything is related to path and path management. And one of the conda's tasks is actually to manage paths for you. I mention this later again in terms of standard daily tips for conda. Okay, the next thing in the upper right, the so-called meta package anaconda. A meta package is basically just a list of package names. So it points to huge lists of scientific package names. In this case, scientific, because anaconda is basically focused on scientific working with Python. So the gray boxes are just packages, and they're all managed by the conda tool. But the meta package anaconda just points to a huge list of packages. So when you install the anaconda package, basically you get more than 100 packages installed, and it's dragging them in via a dependency tree. So basically it's a convenience package. You install once the meta package anaconda, and you can do that with a graphical installer or with a text commands, but more on this later. Okay, so, and the other thing that conda does, apart from package management, it manages virtual environments. And so in my first sentence here, I say, if you only ever need one environment, you could stay with a graphical conda installer. But I found with my students, many cases, once you have either the need for a second environment, or you need to configure settings differently between the base and your main environment. For example, you want to point to Condor Forge always, but maybe prefer to have the conda base stuff from the default channel, more on channels later. Then So if you need to be very precise in how you configure things, they are just much easier to manage with a terminal. So if you're scared of terminal, please get friendly with it, because you become much more efficient in managing your Conda environment and many other things in scientific computing. All right, so the bold printed here, second line, is, for example, a complete line to create a new environment, N for new, N for name of the environment. So create is that it creates a new environment. N is always the command tag to identify the name of the environment. And here then I specify which Python version I want to be really staying sane in your mind. This should confer somehow to the title of the environment. Don't mix it. That would be a recipe for disaster. And then already in this line, but this could be done later. So only, oops, sorry. Only with the, do people see my mouse pointer? Yes?
Yes.
Okay,
Yes.
Good. So if you stop this line, it already creates a new environment for you with the minimum set required for a 3.7 environment. But you can already at this point give some basic packages names that you need to be installed. It will resolve the dependencies. So after this, Conda will suggest you a bunch of, I think, alone these dependency of these 3 packages will create a tree of something like 30 packages that will be installed, just because of all the dependencies. And if for some reason you need to work with legacy Python, which is now called Python 2 because its official support has ended, meaning only very crucial things, bug fixes are entered, but no new development, you can create a Python 2 environment like this. And you don't need to specify the subversion. That basically means it finds the newest of Python 2 that is available and creates for you a Python 2 environment. So this is very comfortable if you have colleagues or work environments where you need to work with legacy code that still works on Python 2, but you also want to enjoy the developments of Python 3, maybe in your own other projects. So you have 2 virtual environments. You can switch easily with them with the conda activate command that I have in the lower right. So with this kind of thing, in the terminal, you just activate a new environment and then you launch your code from there. Or for example, you launch your Jupyter notebooks from there, and then they have automatically the right environment active. But you can also switch these, and more on that later. In the Jupyter Hub, you can switch between different kernels if you need to develop a code that needs to be running in more than one Conda environment. Okay, a quick summary of my Python package search tree, I call it, because people often ask me, it's like, what if the package is not available on Conda? So first, let's start with Conda. Conda install package name. You can actually, without danger, do this because it always will ask you if you really want to do it. So the dependency resolver will tell you now if it would lead to downgrades of other packages or something horrible like that, and you know that would mess up your environment, then at that point you just type no at the end of this suggestion tree, and you would say, okay, that's fine, I have to solve it somehow differently. But what if a package is not available in Conda and my students ask me, can I really without danger install it with pip then, because they found it on pip? And indeed you can, and since recent Conda versions, pip became a first-class colleague of Conda, so they really work well together. And pip also very cleanly removes packages again if you need to. So pip install package name, but what's important, do the conda activate environment name before this or anything really, because it's always helps to be clear in which conda environment you work, because this pip command, as I said before, relates to your currently active Python install. Only then you can be sure that it will be added to the other matching packages that you need to collaborate with this package that you install. And this is true for Conda, but also not if you have, for example, a path setting that points. In case you don't work with Conda, many people, for example, do pip, and if you have no Python installed, it refers to your system Python on the Mac, for example, then it would even ask you for the root password or something like that, because the system Python is root protected, and people just do it without thinking much. And then they maybe have they install a different Python on top and wonder, where's that pip package ever gone to? This is because these things always depend on a current active pip. And this is why all Conda environments always have their own pip, because it always relates to the current active pip. And by the way, if the binary package is exactly the same thing, Conda hard links these packages so it saves disk space. You don't, if you have 10 environments, you don't have factor 10 of disk space usage. It's not factor 1, because sometimes they need for safety copy new versions of it, but it's not factor 10. So where Conda can hard link these, they will be hard linked. Okay, yeah, I mentioned this. If you ever did a pip install and then Python has still had an import error, the cause is most likely that not the correct active thing, and not the correct environment was active at the moment you installed it. So now, what if the package is not even on the PyP server? So then you can GitHub clone a repository if you find it, and you can do Python setup install. And actually, this is something I forgot to update. I don't recommend Python setup install anymore. I recommend pip install, because pip is much better in cleanly removing things in case things are messed up. So please ignore this and replace that with pip install and then dot if you are in that folder. But we can have a discussion about that in Q&A if we have time for it. And this mix I'm using for many years successful. First Conda, then pip, then GitHub server. And I have very stable Conda environments with that. And only when I try to debug things and help the open source community to find why something is not working, then I mess up environment. And that's why I learned how to completely wipe and reinstall things, because usually this doesn't happen anymore, at least. All right, so in summary, just as a reminder again, Conda is the executable that manage packages, not only Python, but that's the big difference also. People ask, can I not live just with Python? With pip. And yes, you could, but then you have to manage the binary installations of OpenCV, of GDAL libraries, and so on, because that's not served by pip. Pip is purely Python, while Conda is something like a package manager like APT or like Yum on Linux systems. So it can do more than Python for you. Okay, so Conda is the executable tool that manages everything. Miniconda is the minimum set. And use this if you understand Conda well, and if you want to, in detail, control what packages you add. Anaconda is a big meta package, and it's really good for beginners that just want a huge list of scientific packages and want everything together and installed, and they don't want to bother anymore. So, as an inferred logic, I hope you understand now, if you would install Miniconda and then execute conda install Anaconda, you actually have the same Python environment as somebody that downloaded just the so-called Anaconda distribution, because the same things are happening in that case. All right, a few everyday Conda terminal tips. If you have installed it before, like years ago, and it's older than Conda 4.6, please, I advise you, remove and reinstall everything, because there were big changes in 4.6, or maybe you have even on Conda 3, same tip applies. And now, since 4.6, the Conda dependency resolver is much faster, so you will have a much happier life if you install a single new package, because it will be much faster in resolving what's needed to be changed and what not. And I personally experienced myself. I had 4.5 to 4.6 updates, and something was just not working really perfectly. And after I removed everything, when I switched to 4.6 and reinstalled it, everything was really good and fast. So if there's something odd with Conda, and it is because you have an older than 4.6, I advise you just wipe your Miniconda or Anaconda environment and start from scratch. If you still have changed path changes, sorry, that's bad English, in your bash C shell, T shell configs, remove it. This is official advisory of the Anaconda company, because they are now, since 4.6, do things, no, since Conda 4 even, they do things with a conda init command that puts a whole section into your bash and T shell and C shell configs, which manages your paths in even finer detail than just adding things to your path environment variable. So, and this double setting ups of having your path manually pointing to your Anaconda environment, and then the conda init session that it will be added by this, that can create problems. So you should not have a manual pointer anymore to your Conda environments. There should be now a Conda init section in your shell setups. Other tip: don't use the initial Conda-based environment that everybody gets when you install Conda for general work, because eventually something of your trials and so on will mess up, and then you would need to reinstall all that. So it's better and much cheaper in your time to always create a new default environment, like I show now, like this, and work in that and mess up that one, because then you can just remove and recreate an environment, but your base environment with the Conda is still active, nothing is broken there, and your Conda is not broken. So I would always advise to work in a default environment that I always call based on the Python version I need. Okay, so if you have questions about that, we can talk about it. By the way, I also have a Conda channel that I not maintain, but I will be always happy to answer questions in the Conda channel in the Open Planetary Slack. This we already discussed, Conda install package, yes, okay. Conda channels, that's an important concept to understand as well. That's basically the source of where you get packages from. So the default channel, which is here in the lowest priority for me, is always there. But the package versions are lagging behind the environment, sorry, the versions of what the Conda, not only the Conda, what the scientific community is working on. So because they're a company and they have, of course, restricted resources, they cannot update everything in real time. But there's a community that has created a different channel called Condor Forge, and they've created very advanced scripts to automatically kick off new version creation of Conda packages and things like that when they're uploaded in certain styles and fashions, which is going far too much for this tutorial. So that I very trustworthy, sorry, that I for years, I used the Condor Forge channel just because I like the newer bug fixed versions where bug fixes are appearing much faster than on the defaults channel that is managed and maintained by the Anaconda company. So I recommend to switch your general working environment to the Condor Forge channel. That's nothing complicated. And I have the instructions in a later slide how to do that. But this is basically how you check what your current system is doing. You type conda config show sources, and that shows the whole config for the currently active environment. You see the upper part is the general Conda environment where I don't pin packages, but underneath that, there's an environment-specific configuration, and I'll come to that later. That's very useful and very often forgotten that this is possible. I pin packages to the Condor Forge channel, and I have a channel priority that I first always look in Condor Forge, and only then would look in default channel. And when I say I mean the Condor tool. When I operate the Condor tool, it will always look first in Condor Forge and only then in default. And the lower left comment here, the topmost channel has the highest priority. That's why it's listed like this. The first one will be searched first. And I have another slide about pinning later. Okay, Conda channels. What if you want to have one environment pointing to defaults channel because you for some reason, maybe as a company, you want to trust more the company thing, but you want to try out Condor Forge. So you can do these configurations environment dependent, and that's a little bit under advertised. I think that's a genius feature by the whole system, that you can do things depending on your environment. So you know that this environment is maybe the default environment where you don't mess with Condor Forge because you don't trust it yet, but you can do more advanced things in different environments. So the way you do this is you add this little env tag, --env or --n, when you do configuration of your Conda environment. And the full way to do this is conda config env. And if you leave this out, it will put this for all your environments. And that's the big hassle I had with my students. They wanted a environment that points to Condor Forge and other one not. Then you need to add this env, otherwise it wouldn't work. And there was a long time where the GUI even couldn't do this, while the command line obviously was able to do this. So maybe this has updated, but I'm honestly not working with the GUI much. So adds mean it adds things to your conf. This is in which section. So in the channels section, I want to make a change, and then I add Condor Forge, and then it will always automatically put on top of any existing channel. And then good tip, don't mix channels within one environment, and pin packages to be sure that you don't mix things. And I have more on this later, maybe on the next slide. Yes. So because Conda sometimes, very rarely these days, but sometimes finds better packages at the default channels. In old times, it would mix from Condor Forge and defaults. And that was catastrophic specifically for GDAL because they had different packaging philosophies on the Condor Forge versus the default. Meaning if the binaries are included into the package, so statically bound versus soft bound and things like that. So it really wasn't working if you would mix it. So stay within one channel for one environment is my general advice. Otherwise, you really need to be understanding what you're doing if you mix things. And this is how you do pinning a package. So again, environment specific, and then add pin packages. And this is the syntax for it: channel name, a double colon, and then a package name. And that would ensure that I don't allow any GDAL stuff coming from the default channel. So for things where you know that's maybe iffy, and I do this for, as you have seen before in the slides, I do this for OpenCV and for GDAL, for anything that is heavy on extra binary stuff or libraries that come with it, I prefer to pin. Even so, it might not be necessary anymore, but this always depends on the dedication of people to manage this cleanly and separate that between channels. So I might as well support Conda in basically not allowing it to wildly mix things. All right, I think I'm running soon out of time. I want to mention this. This is a very important package, one of the most important ones if you have more than one environment and you work with Jupyter Notebooks or Jupyter Lab a lot. Because when you want to switch kernels from between different environments, this package makes your life a hell lot of easier, because you don't need to manually tell your Jupyter servers where to find all your Conda kernels and so on. This package will do this all automatically for you. So one of the most important packages in the recent years, because I hated to configure Jupyter in a way that, oh, I have a new Conda environment, so where's the different kernels now to find and so on. This one will just automatically add all these kernels, see how many kernels I have, and I want to switch and test run my Python code in a different Conda env. I just, here in the upper right, you find how to find these switches. I can just switch fluently between different environment and run the same code in that. So just as a side note. Okay, now the last part, how to reinstall everything in 5 minutes. So even a stable env, initially I called my environment stable, but then I realized that becomes meaningless after a while. So, so I renamed my environment for the Python version. That's just the most mentally sane for me. So with trying out things, uninstalling, reinstalling, everything is rotting at some point. And there is even a technical term, code rotting, and that relates more to programming, but I think there's something like environment rotting as well. There's a truth to that. There's always something happening. So the trick is just to have 3 files, because you will most likely develop a Python package or something like that as well in your life. So how about what happens to that? You want to install it in your Python stack as well, right? But you also want to reinstall things with a list of your favorite packages. So all these you can put into config files. And then I just wrote a tiny, clever bash script, which I share via a link on the first slide in a gist. You just write down, and this little bash script guides you through reinstallation of it, and it finds, I have hard-coded the path to my standard packages in that bash script. Of course, you could make that more dynamic if you need to, but basically this is all what you need, because Conda can be given a list of your packages, and it will install from that file. And then you need a list of your favorite packages as well. And then I have a little script that goes through all my libraries that I developed myself that I need to be known in that environment as well. So 3 things: conda packages, pip packages, and the folders that the pip should go through to install my private packages. And that way, we're running through the script, everything is as it was before. I'm actively developing these private packages, and I want them to be known in the conda environment. And this is done by going into that folder, pip install dot, or usually I do pip install -e dot, because then all my changes are becoming immediately active. Ask me about that if you don't understand that. And that's it. So here a little bit, just this is all delivered in the gist as well, but in the upper left, this is my current script. It also reminds you when you're currently active in that environment and you want to remove that one, it actually tells you deactivate that environment first. So because you can't basically pull the wood underneath you away, removing the environment you're currently in. So you should conda deactivate, and then that script will remove that. This is basically the lines: conda env remove environment name, then it conda creates a new one focused on Condor Forge in my case, but you can of course edit that out. And then the Python version, you can control that with that little script. And then it installs from a file that I have standard py3 conda packages. That's just a list of all the packages I like and I need. So that's the first script. And this is what basically happens. Conda deactivate. So that I still need to manually do. I conda deactivate my conda environment. I run the script on the left like so. Then I conda activate it because and then install my libs, which is this one, because that one, of course, needs to relate to the currently active conda environment. So this goes through my Dropbox source folder, and it goes through all my privately developed packages, goes in there, does a pip install -e, and done. And then when it's done, it goes through my favorite pip package that are still missing and that are not available on Condor Forge yet. So that's it, basically. And oh yeah, that was all my presentation. And I'm happy to take any questions if we still have time.
Thank you. I'm going to hold questions until after the next presentation. Also, okay. Michael is active on the Open Planetary Slack channel. If you have any questions on there, we have all sorts of experts in technical topics.